we have to study a rate of disappearance and a rate of appearance. This is the heading to that we have to study. Here, suppose that reactants are producing products. So one thing, the one concept that you should note here, uh, rate is never negative. A rate is never negative. So it is not possible to encounter negative rate. This is the important concept. The second concept here, delta, which is symbolized as this. This is final minus initial. Final minus initial. This is the mathematical funda that delta means always final and minus initial. This is the funda of the delta. Usually in the science, when we write delta, it means final minus initial, and the rate of the reaction, that is not possible to write that negative. So now here we are writing R to P, reactant to product. So here a rate which is to that we cannot write negative. So we can say the concentration of R, reactant, at the initial state I, concentration of reactant I, minus concentration of reactant F upon time taken. This is delta T. Why we are writing I minus F? This is because rate, it is not possible to write rate negative. Negative rate is not possible. Why we write this? Because negative rate is not possible. That's why here we write initial minus final, because this is going to decrease. This is decreasing trend. This is going to decrease. This is decreasing. When this is decreasing, it means the initial will be more than the final. It means because it is decreasing, so initial will be greater than final, and because we have to keep the rate always positive, that's why we write here initial minus final. Here this is representing the T. Now friends, what we have to do? We have to write the concentration in terms of what? Delta. We have to write concentration in terms of delta. Now we have to bring or we have to write concentration in terms of delta. So what is the funda I told you about the delta? That is final minus initial. That's why here what we are writing here rate of disappearance of A. This is equal to what we are doing? We are placing the minus sign. Why? Why we are placing the minus sign? Because we have to write it final minus initial. So final minus initial or final minus R initial upon delta t. It means we are taking minus, this minus common from here. Look here, we are taking minus common. This from here we are taking the minus value common from here. This one we are taking the minus common. When we take the minus common, then it is minus this one. Now here we can write minus delta R upon delta t. So if someone asks from where this minus sign is coming, then you can answer clearly. We have to bring the concentration, we have to write the concentration in terms of delta, and this delta is mathematical approach. This is mathematics, and when we have to write the delta the change, the delta of the concentration, then we have to take here negative as common, final minus initial. That's why this negative is coming here in the rate expression. Now one thing, students, rate of disappearance, in short I will write is ROD. So whenever you look ROD, it means rate of disappearance. Now yeah, it is clear now that the reactant that is minus delta R upon delta T. The same thing we have to look here about the products. What is the trend in the products? It is increasing. It is not decreasing. It is increasing. Products, they are increasing. They show the increasing trend. So they show the increasing trend. So we can say rate of appearance of here P, and here it should be R. It means reactant R. So here rate of disappearance of P, here is P, rate of appearance of P, which is product, and here it is reactant. In short, ROA, rate of appearance, we will write here. Since this is showing the increasing trend, it means we can say product final concentration minus product initial concentration upon delta T. Here in this case, the product final concentration, this will be greater than product initial concentration, because it is showing the increasing trend, and we know the negative is not possible, and here negative is not coming, and it is now easy to write it in the form of the delta, because it is directly written final minus initial. So it is delta product concentration upon delta T. So dear students, here it is mathematically it got the negative sign, and mathematically it got the positive sign. So there is no any concern of the just telling without any concept that the disappearance means the negative and appearance means the positive. This is not the right way to teach the science students. The concept is rate is never negative, and the concept of the delta is final minus initial. It is showing the decreasing trend. It means we have to write in as this. So mathematically, this is the mathematical operation. That's why the disappearance got here the negative sign and appearance got here the positive sign. Now students, after this we have to just know about the little stoichiometry. Here stoichiometry. Stoichiometry means balanced equation of reaction. Example, balanced equation of the reaction, that means stoichiometry. And example, 3I2 plus 6 NaOH producing NaIO3 plus 5 NaI plus 3H2O. This is the balanced equation. That's why this is called stoichiometric equation. The next thing to that we can write 2KNO4 plus 16 HCl. This is 2KCl plus 2MnCl2 plus 5Cl2 plus 8H2O. This is also a balanced equation. That's why we can say this is the stoichiometric equation. Suppose that this is alpha A plus beta B. This is producing gamma C plus delta D. This alpha is called a stoichiometric coefficient of A. This beta is called a stoichiometric coefficient of B. This gamma is called a stoichiometric coefficient of C. And this delta is called stoichiometric coefficient of D. So friends, these are the stoichiometric coefficients. Now the rate and the stoichiometry. Rate and the stoichiometry. What is the rate and what is the stoichiometry? Here we can say the next heading is rate and stoichiometry. Here I wrote alpha A plus beta B. This is producing gamma C plus delta D. We can say here what is the relation between the A and the B. What is the relation between A and the B? It means we can say here when alpha moles of A take part in the reaction, then beta moles of B take part in the reaction. This is the stoichiometric coefficient. Stoichiometric coefficient. This is telling when alpha moles of A is participating in reaction, is taking part in the reaction, then beta moles of B is taking part in the reaction, or we can say alpha moles of A are reacting with beta moles of B. Now, we can say here minus delta A upon delta T. Here we can say minus delta B upon delta T. Here, this is rate of disappearance of A. This is rate of disappearance of B. What we told her? Alpha moles of A or alpha concentration of A is reacting with the beta concentration of the B. So if we have to equate them, then what we should do? We should multiply this with beta and we should multiply this with alpha. Yes. To make it equal, we have to multiply these. To make it equal, we have to multiply this. Because alpha moles of A or alpha concentration of A is reacting with beta concentration of B. So, how we make it equal? That's the way by which we make it equal. We can say here 1 upon alpha, and this is delta A upon delta T, and 1 upon beta, this is delta B upon delta T. This is the thing. The same operation we can do for these all, and the same way we can say here it will be 1 upon gamma and delta C upon delta T, and 1 upon delta into delta D upon delta T. This is the rate of appearance of C, rate of appearance of D. Now, I don't think it will be 100% clear to you. Definitely, you should have little confusion. So we have to take the example to make it very clear. We have to take the example to make it very clear. Now, suppose that here we are taking example A is reacting with 2B and producing 3C, like this. We are writing this in the same, in this manner. Here we can say 1 mole. Here we can say 2 mole, or here we can say 1 molar concentration, and here we can say 2 molar concentration. When 1 mole of A is reacting with 2 moles of B, then they are producing 3 moles of C, or 3 mole per liter of C. Now, dear friends, we have to learn the relationship between the stoichiometry and the rate. Finally, here what we did, here we write delta A upon delta T with the minus sign. Here what we write, delta B upon delta T with minus sign. Now here these are two things. If we want to make it equal, then what we have to do, when it is 1, then it is 2, and we have to make it equal, we have to equate these. So for equating here, multiply by 2, because when it is 1, then it is 2, and if you want to make it equal, then here in this case you have to multiply by 2. This is the thing. That's why here we are multiplying by 2. And if we simplify this, then delta A upon delta T, this is equal to 1 upon 2, and minus delta B upon delta T. This is the thing. This is the reality. After this, the same way, if I write it again, I'm writing it again, don't worry. Suppose that I'm writing here A plus 2B and producing 3C. Here we can say uh, uh, when it is 2 moles or 2m, then it is 3 moles or 3m, or just change it little change it and make it a little more clear, more easy. So changes, let relate with this one, it will be easy. 1 mole and this is 3 mole. Here it is or 1m, here it is 3m. Now friends, if you have to equate these, if you want to equate these, then you have to multiply it by 3. Listen. So in terms of rate, you can say minus d, sorry, don't write d, it is right here, delta A upon delta T, and multiply it here by 3. This is equal to delta C upon delta T. In more simple way, delta A upon delta T is equal to 1 upon 3 delta C upon delta T. Now friends, you have this one equation, this is the equation, this is equation number 1, and this is equation number 2. So what you can write, you can conclude here now, you can write here what, minus delta A upon delta T, it is equal to 1 upon 2, and minus delta B upon delta T, this is equal to 1 upon 3 delta C upon delta T. So friends, what was the stoichiometry here? In this case, it was A plus 2B producing 3C. It was the stoichiometry. So here you divide it by 2, the stoichiometry, you divide it by 3, it is the stoichiometry. So by this way, with this, by this simple example, what we learn, what was our learning? Learning is, if alpha A is reacting with beta B and producing gamma C and delta D, then what? 1 upon alpha into delta A upon delta T and 1 upon beta, delta B upon delta T and 1 upon gamma, what? delta C upon delta T, and what? 1 upon delta D upon delta T. These are the findings. This is our final finding, final conclusion. So you have to divide the rate of a particular substance by its stoichiometric coefficient, particular substance by its stoichiometric coefficient, rate of particular substance by its stoichiometric coefficient, by its stoichiometric coefficient. What this value is, what this value is, this value particularly I am telling you what this value is. This is rate of disappearance of A. What this value is telling to you, this is rate of disappearance of B. What this value is telling to you, this is rate of appearance of C. What this value is telling to you, this is rate of appearance of D. So you can say here, for this particular stoichiometry, you can say here rate of disappearance of A divided by its stoichiometric coefficient, rate of disappearance of B divided by its stoichiometric coefficient, rate of appearance of C divided by its stoichiometric coefficient, rate of appearance of D divided by its stoichiometric coefficient. This is the final judgment. Thank you very much. Thanks a lot.